Module. Call this the big boy module, because we have to focus. This is now, it tell we say, we know question 3 and 4, module 2 is now vectors, trigonometry, coordinate geometry. So now it gives us this right here. The vectors P and Q are these. Calculate the angle between P and Q. Well, that's easy. Let's just go through this really quick. It gives us the vectors P and Q, and it wants the angle between P and Q. So all we need to remember is one simple formula. All right, so this is what we have. So let the angle between P and Q be theta, right? Let that angle be theta. So if we're calling the angle theta, then we know that the cos of theta is going to be equal to P dot Q over the magnitude of P times the magnitude of Q. That's a joke question, really? But let's just do it real quickly. So now what we're going to get is that the cos of theta is going to be equal to P. P is 6, 4. Remember, the I component is the X, so just write 6, 4 dot Q, and Q is minus 8 minus 9. This is now minus 8 minus 9, and it is divided by the magnitude of P times the magnitude of Q. The magnitude of P, remember the magnitude is the square root of 6 square plus 4 square, and they will work out the magnitude of Q. So multiply also now by the square root of minus 8 square plus minus 9 square. Minus 8 square plus minus 9 square. We know so square the negative that gone. So put a bracket, all right? So let's simplify now. The dot product will be 6 times negative 8, that's minus 48, plus 6 times minus 9 times 4, I think that's minus 36. And then that is divided by 6 square is 36 plus 4 square is 16. 36 plus 16 is the square root of 52. Then that is being multiplied by 8 square is 64 plus 9 square is 90. Is that 91? 81. 81 and 64. That is, what is 81 and 64? 135? I'm not even sure. All right, 145. 81 and 64 is 145. Thank you. All right, come on, quiz man, come on. All right, so let's go now and just do this in our calculator now. So we're just gonna do it in our calculator here, just to work out the angle. So we end up got, it was the dot product, which was, we got, just make the calculator do it for us, minus 6 times minus 8 plus 4 times minus 9. Then we divide that by the square root of, this was 6 square plus 4 square. And then it was being multiplied by, bring it out, multiplied by the square root of, this was minus 8 square plus minus 9 square. Why is it taking away the bracket? Good, plus minus 9 square. All right, guys, you realize our calculator smart, you can put everything in a calculator. Negative 0.967. All right, so this worked out to be negative 0.967. When you do that now, since the cos of theta is that, then you know, so theta is cos inverse. So theta is going to be cos inverse of that number, and then that's the angle between P and Q.
Sir, seeing that it's negative, you're going to have to consider the other quadrants, right?
No, just take the cos inverse. When it's vectors, you don't need to consider any other quadrant. Just take the cos inverse. All right, once it's vectors, don't worry about quadrants. All right, let's take cos inverse. That just means it's an obtuse angle. When it's negative, it just means it's going to be an obtuse angle. So that's it, 165.3. That's all it is saying. Because if we were to go to Geometer Sketchpad and put on the graph, you'd realize that probably if we do a rough sketch, let me show you. Let's say we'll do a rough sketch. P is the point 6, 4. So maybe 6 is here and 4 is right here. This is the point where P is. All right, this is P. This would be the vector OP. Then if you want where Q is minus 8, minus 9. Probably somewhere over here, minus 8, minus 9. Minus 9 somewhere up here, so. Wait, that's not minus 9. Minus 9 is somewhere down here, so. Maybe down here, so somewhere is minus 9. So then this would be Q somewhere right here, so. So look at that, Mr. Platt now. All it is telling us that is the angle between P and Q is obtuse. When you get negative, that just means that the angle between P and Q bigger than 90 degrees. Make sense?
Yes, sir.
So the only time you need to worry about quadrants is trigonometry. So by the way, guys, you can't just write theta equal 163, 165.3. They're not going to give you your marks, your full marks. What you have to tell them is they don't know where this theta come from. You have to tell them, so the angle between P and Q is, you have to give them that statement. Angle between P and Q is, then give them the answer you get, 165.3 degrees. All right, they don't know where this theta come from. Or you make up theta, or we made up theta. All right, they don't know where this theta come from. So we have to establish, theta, but then you have to tell them, say, that's the angle between P and Q. Now, they say find a non-zero vector P V such
Second.
that,
Second.
can
Just
repeat?
scroll up on the paper for a second, please.
Scroll up. The white right here.
No, the other one, the actual possible.
You want to scroll up?
Yeah, just for a second. I just want to
Okay. Okay. All right. Give me a second. I need to get it off this. Right here.
Where's it? Sir, number 2, sir. Number 2. No,
The
number 2.
two.
Oh, 6 marks. Okay. Sorry.
All right. All right. Nice. All right. Now this part here, so now it says find a non-zero vector v such that p dot v equal 0. So now, guys, you want to find a non-zero vector v such that p dot v equals 0. What you're gonna have to do is call v AB. We don't know what it is. You can call it AB. You don't have to use AB. I want to use AB. So V is AB. Now, if you want P dot V to equal to 0, P dot V equals 0, then that means this is really saying 6, 4 dot AB equals 0. That's the only way the dot product will be 0. All right, AB equal 0. All right, so what this would work out to be is 6A plus 4 times B equal to 0. All right, so what does that mean? That means if you're to bring this over here, you end up get 6A is equal to negative 4B. And so if you divide through by 6, that means A is equal to negative 2 over 3 times B. All right? So what that means is any number you choose for A, B is going to be negative 2/3 of that number. So let's say you choose A as 3, right? Let's continue it here. Let A be equal to 3. If A is equal to 3, then in this case, B would be equal to negative 2 over 3 times 3, which is negative 2. So that's a possible answer. So a possible answer you could tell them then is V is 3, negative 2. That's one possible answer, 3, -2. That's the answer. Or let's say they want to make A equal, I don't know, let's say 6. Or maybe -6. Let's say they say let A be -6. If A was -6 and put -6 here, so -6 times -2 would be +12. 12 over 3 is 4. In that case, B would be 4. So another vector that you could get for a possibility is -6, 4. All right? So that's easy. All right? You just choose a value you want for A and B, and you're done. And they give you 5 marks for do that. Imagine. 5 marks for do this, and you get 3, -2, or -6, 4. Easy, don't it? It's not easy.
Good, sir.
Yeah, man, this easy, man. Come on, man. Say it with confidence. This easy, man. So get that a possible vector V, just to write it here. So one answer we got was V could be -3, 2, -3, 2. The -3 for the up top. Or another answer we get is V could be 6, -4. All right. Is it 6, -4? Let me check back. We choose A as -6, 4. -6, 4. So 3 minus 2 and -6, 4. This supposed to write the other way. -6, 4.
Sir,
And the next, yeah.
state the relationship between P and V.
If the dot product is 0, what's the relationship?
Perpendicular.
Perpendicular. Easy, easy. Once the dot product is 0, then they are perpendicular. So P and V. Guys, because we want exercise sharpness, we now say perpendicular, we're saying orthogonal. Give them the new word. Orthogonal means perpendicular. All right, so P and V are orthogonal. All right, cool with that?
So, sir,
Yeah.
find the non-zero vector V such that PV equals 0. Would let
A,
P.
it says find A, meaning you have multiple.
Oh, okay. A.
Find A, multiple is there. All right, multiple is there. That's all they're telling you. And we already found a couple. We found 2. We established that right here. So one possible answer is 3 minus 2. Because look, if A was 3 and this is -2, 6 times 3 is 18. Wait, 3 minus 2 here, so this is 6A plus 4B carried over. This is divide through by 6 minus 2 over 3B. If A is 3, 3 times 3, yeah. So put in this here, so now 6 times 3 is 18. Plus 4 times -2. Wait, 4 times -2, what is that? 4 times -2 is what?
-A.
-8, but this wouldn't give us 0. What happened there? It's supposed to be the other way around. Let me see. Bring over this. Divide through by 6. Divide through by 6. So if we're to choose B, if we choose B as, oh, you don't see what I did. I'm telling you let A equal 3, but in this case, it's really B I put as 3. It's really B I put as 3 now. That's how the 3 cancel the 3 and the A is -2. Thank you, Javon. It's really the other way around. When I say A as 3, it's really let B equal 3. Guys, follow. Thank you, Javon. It's really B I put as 3 right here. So if 3 is here, so the 3 cancel the 3. So A would be -2. Thank you, Javon. This is supposed to be A as -2 then. So much giving away today. Oh God, it must be I don't even know. This is -2, 3.
Monday, sir.
All right. Monday is a fresh day, so I shouldn't be making any mistake. It's -2, 3. No, it would work. Look, 6 times 2 is 12. plus 4 times minus 3, that's 0. So that's minus 2, 3. That would work. So we also need to flip it around the other side because this is really choosing b as negative 6 here. So this is 4 minus 6. So thank you, Javon. This is 4 minus 6. And so this should have been A, and this should have been B here. All right, so nice. It's minus 2, 3, and 4 minus 6. I need to fix that.
Sir, why did you switch it to the other way around exactly?
All right, I'm going to go back on it and show you why. This was minus 4, 6. Was it minus 4, 6?
Yes, sir.
Yeah, let me show you why we switch it around now. Right here, so no, it's 4 minus 6, not minus 4, 6. Why we switch it around was right here, so it's really B we put as 3, because when you put 3 here, so minus 2 over 3 times 3, the 3's them then cancel. Does that make sense?
Yes, sir.
And then now we'd get A equal negative 2, so that's why we switch it around. Down here, so it's B we put as negative 6 again to make negative cancel. And so we get 4 minus 6. Then now we state that they are orthogonal. All right, nice. Put the minus down here, so. All right, so now let's wrap it up now. It gives us this right here. It says the circle C1, which is the circle C1, which is minus 3, 4, and 1, 2, are endpoints of a diameter. So what they're telling you is they give you a circle and they give you the endpoints of the diameter, minus 3, 4, and 1, 2. 1, 2 is positive, so maybe 1, 2 is here, and maybe minus 3, 4 is here. All right, maybe this is how it looks, and they give you that. And then they say, no, this is the circle. Show that this is a circle, where this point is 1, 2, and this point is minus 3, 4. Find the equation of the circle. That's literally what they're asking you to do. So now to find the equation of the circle now, or to prove that this is the equation of the circle, we need to find the center. Now to find the center is just going to be the midpoint of these two, don't? Right?
Yes, sir.
So the center of the circle is going to be the midpoint. To get the midpoint, it is just minus 3 plus 1 divided by 2. That gives us the x mid, comma. The y mid now is just 4 plus 2, and we divide that by 2. That will give us the y midpoint, and we're nice. So now we end up getting that the center of the circle is just minus 3 plus 1 is minus 2 over 2, that's negative 1, comma, 4 plus 2 is 6. 6 over 2 is 3. So the center is minus 1, 3. This right here, so is minus 1, 3. Now that we have the center, we need the radius. Now, since we have this right here, so we can find the radius, because the radius of the circle is then the square root of, it is x1 minus x2 square. So it's 1 minus minus 1, that become 1 plus 1 square, plus y2 minus y1, 3 minus 1 square, 3 minus 1 square, that gonna give you the radius. So the radius gonna work out to be 1 plus 1 is 2, 2 square is 4, that's 4. 3 minus 1 is 2, 2 square is 4, so that's 4 plus 4 being square rooted, and so the radius is the square root of 8. That's all they're saying. The radius is the square root of 8. Now, if the radius is the square root of 8, we don't really have anything to worry about, because now we have the center and we have the radius. So now the equation of the circle is going to be given by x minus the center, x minus minus 1. So it becomes x plus 1 square plus y minus the y value at the center, y minus 3 square, and that's equal to r square. What is r square? We'll find out that r is the square root of 8. So r squared is just 8. Then we expand it now. First term square plus twice the product of the two plus second term square. Then we expand out y now, we get plus first term square minus twice the product of the two plus second term square, and that's equal to 8. Yeah, man. So now all we do now is we group up we like terms, or maybe you can group it by descending power. So we'll go x squared first plus y squared plus 2x minus 6y. Then look at this. 1 plus 9 is 10. So we have 10 here, so. And then we can, let me see what they want us to
Sir,
show.
sir, wasn't it 5?
They have 5 here.
What
Wait,
did you?
let's check back this. 1 minus minus 1. 1 minus minus 1. That's 2. 2 squared is 4. 2. 2 minus 3. Oh gosh, where does 1 come from? Giving
Sir,
it away.
sir,
So you're tired, man.
Yeah. All right,
Monday
3.
stuff.
Yeah, Monday. Like, this is crazy. So this is 3 minus 2. 3 minus 2 is 1. This right here, so, is 1, right? This right here, so, is 1. So this is now 5. This is really, really sad, right? Too much mistake, right? Giving it away. The distinction gone. Distinction gone, right? So, guys, you see, rest is extremely important when we're doing pure math, all right? When you just going and going, we get tired, all right? And when we get tired, if one thing about math, when you're tired, even the easiest of things are making simple mistakes. So that's another lesson that we have to get lots of rest. All right, so that part now we can add them to get the 10 minus the 5, and now we'll get the 5 that they want. And so guys, make sure say for pure math, we get, well, for every subject, not just for math, but more so for math and physics, you cannot calculate when you're tired, you cannot calculate when you're hungry. So for 2 subjects, math, physics, make sure say your belly full. Well, not full enough, because if your belly too full, you probably feel sleepy. But make sure say your belly, you're not hungry, and make sure say at the same time, you don't tired. All right, so now we'll get it. All right, so that's right there, easy. Now it says you have another circle, and it says C2 is that circle, find the points of intersection. So we have another circle now, which is x squared plus y squared plus x minus 5y equals 0. So can we just write down the 2 circles that we have? So then give me a next circle now. X squared plus y squared, and this is plus x minus 5y plus x minus 5y equals 0. Now the first thing we need to do is find the line of intersection. So from the 2 equations to find the line of intersection, realize if we were to subtract them, let's subtract them. X squared minus x squared gone, y squared minus y squared gone, 2x minus x left us back with x, minus 6y minus minus 5y, minus and minus become plus. So that become minus 6 plus 5, which is minus y. 5 plus 5 minus no number is just plus 5, equal to 0 minus 0 is 0. So from this now we can make y the subject. We end up realizing y is x plus 5. If y is x plus 5 now, we can substitute it into any one of the circles. Now since this circle do have no constant, I'm going to plug it into the second one since that look easier. So we're going to get x squared plus y squared become x plus 5 all square. Then that become plus x minus y becomes Minus 5 times y, sorry, becomes minus 5 times this. So it becomes minus 5x minus 5 times 5 is 25. So minus 25 equals 0. So solving this now, we can expand to get x squared plus first term square x squared plus twice the product of the two, that's 10x, plus the second term square of 5 squared, which is 25, plus x. All right, then we have minus 5x minus 25 equal to 0. So all we need to do, guys, now is we just need to group our like terms, of course. X squared and x squared, that are 2x squared. Then we'll group up our x terms. We have with 10x, with x, and with minus 5x, that are 9x, 11x, minus 5x, that's 6x. Just to go through one more time, because we know kind of weary, so that's 11 minus 5, that's 6. Good. Then we have 25, and then we have a minus 25, so that gone. So 25 them gone, so we now have no problem. 25 minus 25 gone, so good, equals 0. We can factor out a 2x, and we're left back with x plus 3 equals 0. So what we end up getting is, from this side, clearly x equals 0 if 2x is 0. So if we have x equals 0, then this side is x equal to negative 3, because x plus 3 is 0. But if x is 0, we end up get our y value, and y is put 0 right here. We get y is 5, and then put negative 3 right here. Negative 3 plus 5 is 2. That give y equal 2. So basically what we get is x is 0, y is 5, comma, right here, so we get negative 3, and y is, of course, 2. All right, so 0, 5, and negative 3, 2. All right, easy as that. 0, 5, and minus 3, 2. Soft. Like we literally have to tell them, so this question was too easy. You can tell them, just write pen and paper, so this question was too easy. All right. 0, 5, and what was the next point? What was the next point we got? Oh, minus 3, negative 3, 2. All right, negative 3, 2. Now, as you know, I love when we check our answer. If you check your answer, two of the equation them supposed to be satisfied. Meaning, if we put 0, 5 in here, if x is 0, it would become 0 plus 5 squared, which is 25, plus 2 times 0 minus 6 times 5 plus 5, it's supposed to be 0. So we're just going to check it with one of the equation to make sure, say, we never make no mistake. We'll have to check it. Let's say we're checking in the first one. Let's try negative 3, 2. Negative 3 squared plus y squared, that's plus 2 squared. Then you have plus 2x plus 2 times negative 3 minus 6 times, this is now 2 plus 5 was supposed to get 0. We get with 0, so we know so points them correct. All right, so if the question too easy, guys, we can tell them this. This was too easy. You can write that in and tell them soft. Yeah, man, you can tell them soft. Tell them, make them know this was too easy. All right, make them know. Yeah, man. Then what they have to do is go look back and say, ooh, for paper this, man. They must say them college man is so sharp. Yeah, man, make them say this. This was too easy, soft. Yeah, man. Tell them that, man. All right. Now this question here, now this is the real one that I like us to look at, which is trigonometry. All right, because oftentimes this is where I notice that most times this is where we're like super
That
having difficulty.
was worth 9 marks.
Yeah, that was worth 9, don't it? It shouldn't even worth 6. Should have worth
Where,
5.
where did they distribute the marks exactly?
Remember I told you how they distribute. Let's say there's a case where all the marks add up to 137. Then you're gonna have to throw on some marks on some question, make it add to 150. Let's say everything add up to 160. Then I'm gonna have to squeeze out some marks, make it balance to 150.
Mm.
So that means that some year you might find that it's longer and less marks. All right, so
You have to write the point of intersection is those two things, right? I can't just leave.
yes. Don't leave it like that, right? That the points of intersection are 0.5 and minus 3.2, right? Yeah, that's the concluding statement. All right. Now this question right here, guys, I love these type of trig. It says solve this equation where a is between 0 and pi. Guys, notice a is between 0 and pi. And we need to solve for all the possible solutions of a. So look how we're going to take this on now. Serious business time. Why this right n? It should have been pi. All right. So solve this now. So guys, if we're solving this equation, right, first thing we do is draw a circle and say where cos is positive. Cos is positive in the first and the fourth quadrant. So what we end up get is 3a. In the first quadrant, you get that 3a is cos inverse of 0.5. Cos inverse of 0.5 is pi by 3, don't it? That's 60 degrees. Go know that the cos of 60 is a half. So that's pi by 3. Now down here, so it's going to be 2 pi minus pi by 3. All right? And 2 pi minus pi by 3 is 5 pi by 3. Just want to make sure no addition mistake is met. Yeah, so that's fine. So now these are the two answers now we get. We get that 3a can equal to pi by 3, or we end up get that 3a can equal to 5 pi by 3. Now, gentlemen, here's where it gets crazy now. Now, don't think this is going to give 4 marks. It's the divide through by 3, you're done. No, guys, you can spin around the circle one more time. You can spin around the circle one more time. So the next answer you can get is pi by 3 plus 2 pi. You might say, sir, why would you want to go around the circle one more time? I'm going to show you why we're going to go around the circle one more time. A, you want all the possible values, so A is between 0 and pi. If you only give them 2 answers here, you might short one answer. So anytime you see a 3a here, so chances are you need to spin around the circle one more time to get all the answers. Anytime you see 2a, 3a, 4a, chances are you need to spin around the circle one more time. All right? So what do I mean? For example, all I'm saying is if you work out cos 60, you get a half. If you have to spin around the circle one more time, we know say a 420, but that can also give you the same half. That's all I'm saying. So that's why we're spinning around the circle one more time to get this angle right here. Then if you add this one now, add 2 pi to 5 pi by 3, 5 pi by 3 plus 2 pi. Now you can get all your possible answers, or maybe we get all our possible answers. We're not sure yet. Let's check. So what we're going to get is 3a is equal to pi by 3. Next answer is 5 pi by 3. Then pi by 3 plus 2 pi, if you were to add them here, multiply up this 3, you get 6 pi plus 1, that's 7 pi by 3. Then over here, so that look like 11 pi by 3. So these are the answers that we get, 11 pi by 3. Now to find the value of a, we need to divide through by 3. So dividing through by 3, divide through by 3, and dividing through by 3, what we end up getting is a is equal to, dividing through by 3, you're going to get pi by 9. That's one answer, pi by 9 or 20 degrees. 5 pi by 9, 5 pi by 9, comma, 7 pi by 9, and 11 pi by 9. But guys, you can't stop. The 11 pi by 9 is going to be what? Bigger than pi, though. If this is pi, 11 pi by 9 bigger. Don't it? Because pi by itself is 9 pi by 9, though. So we don't need 11 pi by 9. We can stop right here, so right? So we can stop at 7 pi by 9. This is where we stop. These are the three answers we get. 11 pi by 9 wouldn't be valid. So we stop right there. All right? So that's it. Pi by 9, 5 pi by 9, 7 pi by 9. Those are our answers. And it's that easy. All right? So just to write it right here, the three answers are pi over 9, 5 pi over 9, 7 pi over 9. Couldn't be any easier. All right? Nice. Now, the next part of this question says, we need to show that this is a trig identity. All right? Show that cos 3a is 4 cos cube a minus 3 cos a. We're supposed to tie it for see this module exam, this exam. Them love ask this one.
I hope
So,
the app on the sales paper.
all right?
These strips.
Tired of this and tired of this one now. The cos of 3a. So of course, to do the cos of 3a, guys, you can break it up two ways. You can use cos 4a minus a, or you can do it the easier way and write it as the cos of 2a plus a. And then now we can expand it using the compound angle for cos. Using the compound angle for cos, it is cos cos minus sin sin. So it becomes cos 2a times the cos of a minus sine 2a times the sine of a. And then since you know, so everything needs to be in terms of cos, we know that we're going to have to exchange out sine in terms of cos. So first thing, cos 2a, you're going to have to use the identity 2 cos square a minus 1. And this is all being multiplied by cos a. And then we minus sine 2a. Need to remember this identity is 2 sine a cos a, 2 sine a cos a, but then it is being multiplied by the sine of a. So guys, since it is being multiplied by the sine of a, instead of timesing it by sine a, put the sine a times the sine a and put a sine square here. So now what we're going to end up is 2 cos square a times cos a. That's 2 cos cube a. Then we have 1 times cos a. That is minus cos a. And then over here, so now what we're going to do is, you see this 2 sine square? Remember that sine square is 1 minus cos square. So we're going to rewrite this as 2 times in bracket. Change the sine square now to 1 minus cos square, so that we can have everything in terms of cos. Once you get everything in terms of cos, we're really nice. All right, everything in terms of cos, so we're nice. So what we're going to end up getting now is 2 cos cube a minus cos a. Then expanding this right-hand side. Now, guys, I like to do it in one step. Negative 2 times 1 is negative 2 times cos a. That's minus 2 cos a. Doing it in one step. Then we multiply the negative 2 times minus cos square. We're going to get plus cos square, but then cos square times cos square is cos cube. So we'll get plus 2 cos cube a. Then what we do now is the 2 cos cube and the 2 cos cube become 4 cos cube. And then minus cos a minus 2 cos a, that's minus 3 cos a. That's minus 3 cos a. And you're literally done right there. So literally, we're done. We're nice. All right, 4 cos cube a minus 3 cos a. And that's the proof. See there? We'll prove it. We can do tell them, you just tell them nice. All right, you don't even tell them soft. It's just nice, right? We never have no stress. It's just nice. All right, just tell them that it's just nice. So prove it. This is your right-hand side. All right, you can just tell them nice. You don't need to even tell them nothing else. That's our left-hand side. Right, now let's have a look at this question here. Now it says, all right, we sip some water. It
Sir,
says the
before you
three.
continue,
Yeah,
sorry to interrupt, sir. Could you go back to the last slide for a second, sir?
no problem.
One before the cost trade.
This one. All right. This one, Adam.
Yes, sir. Thank you, sir.
Okay.
Okay, thanks, sir.
All right. So now looking at the next part now. The next part of the question, it says the three roots of the equation 4p cubed minus 3p minus a half equals 0 lie between -1 and 1. It says use the results, use this result and this result to solve it. All right, let's see how we're going to do that now. Use this and this to find all values of p. All right. Okay, I see what's happening now. Nice. All right, guys, so we're going to copy this. They're telling us to use these two results. So let's use the results that they want us to use to solve. So right here, so let's write down the first result. From this part right here, where we're solving this, writing down the answers, remember, we had gotten that A had equal to, just writing down about what we got, pi by 9, 5 pi by 9, 5 pi by 9, and I think 7 pi by 9. This is going to be critical in this final answer. Then the second thing that we just proved that cos 3a, cos 3a was equal to 4 cos cube a minus 3 cos a. This is also going to be critical to help us answer our questions, all right? This is also going to be critical. So let's write down the question now that they ask. So the question they ask now is 4p cubed minus 3p minus a half. So now we need to find p. We have 4p cubed minus 3p minus a half equals there. And they say using the results from above. So guys, look at this. If you bring over this half over here, this just becomes 4p cubed minus 3p equal to a half. But guys, what was a half? A half was cos 3a. But what was cos 3a? Cos 3a was 4 cos cube a minus 3a. So look what we're going to do. What we're going to do right here is let p equal cos a. Look how it's going to make sense now. Let p equal cos a. Because if you plug p as cos a in this question, guys, right? Even though it's a polynomial, look how it's going to work out nice. If you plug p as cos a, you're going to get, this becomes 4 cos cube. This becomes 4 cos cube a minus 3 cos a equal to a half. But guys, what is that? Solving that, this part is just cos 3a. So solving it, we're just solving cos 3a equal to a half. So when a nice man who already know what a is supposed to equal. A is supposed to give with them answer the a that equal to pi by 9, 5 pi by 9, 7 pi by 9. Come on, man, oh, them so boring. So this is going to be a. But see the trick part here now? When you find a, now we need to find p. If this is a, p is going to be the cos of that. So the answers them then is p is the cos of pi by 9, comma, p is also the cos of 5 pi by 9, and then p is also the cos of 7 pi by 9. That makes sense? Go calling p cos a, right? That makes sense?
Yes, sir.
So see it here. You just put this in a calculator. Cos Come on, no man, this easy here. So all we need to do is write them there down. So P equal, see it here, so P equal to the cos of pi by 9. Just to bring out the calculator, I'm just going to put it in decimal. All right, P is the cos of, is my calculator in radians? Not sure, put it in radians. The cos of pi by 9, which is this, 0.939. Notice it lie between -1 and 1. Guys, if you get an answer and it don't lie between -1 and 1, you know so something go wrong. So we get 0.939. That's one answer. Comma, we get P is also 5. Yeah.
0.
Repeat.
940 since you're rounding.
Oh, I want to keep it to, oh yeah, thank you. 940, thank you. 940 is correct. All right, 940 is right. Then we need the cos of 5 pi by 9. Let's change this to 5 pi by 9. That is minus 0.174. This is minus 0.174. And then the last one now is P is equal to, we'll plug in the cos of 7 pi by 9, changes to 7. We get minus 0.766.
Here, shouldn't
Minus, yeah.
only answer 0.940 then?
Repeat.
But isn't the negatives outside of the range?
No, the negative is good. They want between -1 and 1.
Oh, -1 and 1. Okay.
Yeah, so that is good. These are the 3 answers they're supposed to get. Now, guys, look how this beautiful. Why I love this? Because if you're gonna check it in a calculator, let's say they want to solve the answer, solve this. I guarantee you're gonna get these 3. So we're gonna solve this cubic with this calculator here. If you solve it, go up on mode, equation, looking at a cubic 4. Coefficient of A is 4. Coefficient of B is 0. Coefficient of C is -3. The constant D is -0.5. Solving it, 0.939, which is 0.940. That's the first one. The second one, see there's minus 0.174, what we get? The third one, minus 0.766. Guys, we use trigonometry and find the roots of this. Imagine that, a trigs we use and solve this, you know, this is not nice. Math's nice. Math's nice, though.
So you never did have to use trigonometry.
All right.
Never used other methods.
Oh, the Casios that are good for the exams, like one of them we can check this answer again. So Jaim, the Casios that them good is this one. The Casio 570 is good. Casio 570, Casio 115, Casio 991. Those are the 3 ones that can help you. Like do the question them. 115, Casio 115, Casio 991, Casio 570. These are the 3. Any one of them are good. All right. It's just that the 570 more older one, 115, the next one, the 991 of the more recent one. Is one of them you have, though, Dominic? The 991, right?
I have the 991EX.
Yeah. The same thing, 991. Yeah.
So all of them are non-programmable, right, sir?
All of them are?
Non-programmable, right, sir? So we're allowed to use them.
They're programmable, but the thing is the examiner don't know the difference between programmable and non-programmable. Okay. The invigilators that are coming are not math teachers, so they don't know.
Yes, sir.
All right, so that's why you can do them with that. And those are the type of calculators I've always done all my maths exam with right through university, because the invigilators don't know programmable from non-programmable. All right, they don't know. So that's why I'm telling you to get one. All right. So now, this question here now is a nice little trigonometry. It says the following diagram is not drawn to scale and it represents a painting of height h that is fastened to a vertical wall at a height of d meters above, x meters away from the level of an observer, and them tell us that the viewing of the painting is alpha minus beta, and they tell us that where alpha and beta are the angles of inclination from the level of the observation. They say show that the tan of alpha minus beta is h x over x squared plus d times d plus h. All right, so what I'm going to do is copy this diagram so we can do it easier. Let's copy that diagram. Don't see no sugar there. They're just giving us a boring question. I gave something similar to this on mock exam, right? Something with, only thing I did instead of angle of inclination, I said gradient. That was the only difference. So we have this here. Then they give us another triangle in it. This bigger angle is alpha. The bigger angle is alpha. The small angle is beta. And then this height between here and here, and then this height between here and here, they have to give you. Let's figure out what they say. That is h, d, and x. So this is h, this is d, and this is x. Now guys, just to show some random knowledge that we already know out there, we know that the tan is opposite over adjacent. So in that case, the tan of alpha is going to be equal to, this is the opposite, which is going to be h plus d over the adjacent of x, right? That's tan alpha, right? H plus d over x, right? Agree? And then the tan of beta, what's the tan of beta? D over x, beautiful, beautiful. Tan of beta is d over x. Guys, imagine them asking us this boring question. Oh, they want us to find the tan of alpha minus beta. After I hear them talking about painting and all of this, I'm ready to say, oh my Lord, this is going to be nice. Imagine, this is a boring question they want. So this is just going to be tan alpha minus tan beta over 1 plus tan alpha tan beta. All right, so that's the easy question they have right here, over 1 plus tan alpha times tan beta. And all we're going to do is substitute those values right there. All right, this is all we're doing. So plug in tan alpha as h plus d over x, h plus d over x. Then we minus tan beta. Tan beta is d over x. And this is being divided by 1 plus tan beta, which is d over x times tan alpha h plus d over x. Literally, it's algebra. All right. So now, of course, guys, look what I'm going to do. Just because I realize that x times x going to give me x squared, I'm going to rewrite the number 1 as x squared over x squared from now, just so it's easy to write as one fraction. So what we're going to get for tan alpha minus beta is h plus d minus d, h plus d minus d, that d gone, so we get h over x. This is then being divided by, now I'm removing the vernacular sign and putting a regular division sign. Then this would become x squared in the numerator, because this is all over x squared, by the way. So I'm just simplifying this part now. I'm simplifying this denominator. All right, that denominator simplified, what I'm putting in the square bracket here, is going to be x squared plus d times in bracket h plus d. All right, so that is all we have. So now this is the tan of alpha minus beta. Let's finish it off right here.
So
Yeah.
the h plus d is in brackets, right?
Repeat.
H plus d is in the brackets.
The h, yeah, the h, I put h in bracket.
Okay.
Yeah. So now this is just going to become the tan of, in bracket, alpha minus beta. Now guys, you know, so when we divide, we can flip it. Flip it and change the sign from division to multiplication. So it's h over x times, this is now x squared over This is now x squared plus d times h plus d.
27. Nice year. They only gave 1 trick question.
Repeat.
Sir, on the other years, they were giving the module 2 questions with tricks.
Yeah,
Only
man, this one only one. So the square cancel out this, and so it work out to just be, see answer there, h over, in bracket, this is now 1, this is now h over, or hx, sorry, over x squared plus d times h plus d. Now we'll get the answer. Like, this was so boring. Like, I don't see what they were trying to do. What were they trying to do?
words. They were trying to flex their English. Come on.
All they were trying to do is intimidate us with words. All right, that's literally all they were trying to do, intimidate us with words. Right?
Flex the English, you know, so you have to flex it every now and then.
All right. This last one here, see, let's prove the first part. Last part, guys, it's moving angle of the painting minus beta is max when A equals root of H times D plus A. That's when the is maximum. And that maximum angle radians when D is 3, it says calculate the angle in radians is 3. All right. So guys, all they're telling you to do is plug in this E as this. Plug H as this formula, plug X, sorry, as this formula, plug D as 3H, find what is the angle. What kind of boring question this? Plug X as this, oh my Lord. They're so nice. Literally, all they're trying to do is do bag of chatting for make we get flustered. But to start out with what we just found, the tan of alpha minus beta, remember that this is equal to h times x over x squared plus, this is just d times h plus d. Ooh, d times h plus d. All right, nice. And then they tell us that the angle is maximum, and they tell us it is maximum when, I think they give us that h equal to, I don't remember what's h. No, they tell us x, sorry, is the square root of h plus d times h. So that's when it's maximum, when x is needed to be the square root of h times d plus h. All right, h times d plus h. And then right here, so now we have, since this is x, we need now d is 3h. So we're going to plug in d as 3h. Go and plug in d as 3h. By plugging in d as 3h and x as this, we're going to just substitute it in this formula. But before I do that, guys, I'm going to plug d in the formula for x just to make it easier.
I have a small question, sir.
Yes, go ahead.
If you plug D into the X1, then simplify X to make
Exactly, that's what I was thinking first. Let's simplify it first instead of substituting both at one time. Very good, Mr. Platt. That's very similar to how I was thinking. Plug in the D as 3h, so we're gonna have h times 3h plus h is 4h. All right, and then so we have 4h times h is 4h squared. And so we're square rooting 4h squared. And so square root 4h squared, we get 2h. All right, 2h. All right, so when we get this x is 2h, so we have x in terms of h now. We have d in terms of h, so now we can just plug in everything in terms of h. So this is going to be h times 2h over x squared, x is 2h, so this is going to become 2h all square plus d times, d remember is 3h now, so this is 3h times h plus 3h is 4h, all right? guys, writing really bad now, right? Not gonna lie, really tired. We're gonna stop after this one, all right? And remember,
No much.
repeat.
Not doing any much lessons tonight.
No, I'm telling you, man, I'm really, really tired. All right,
Monday,
really
sir.
tired. Yeah, one of these days. It's not because of it's Monday. It's just that this weekend was doing a lot of preparation for this week, put together papers because, as you know, I have AdMath marathon tomorrow. Then I have Pure Math marathon on Wednesday and Pure Math marathon on Thursday. And we still had AdMath class today. And today was the last class of fourth form. And so today was very hectic. And all of my planning I do on the weekend. All right. So really tired. So let's just hurry up and finish this. So my apologies.
Yes, sir.
All
The
right.
man is going to be in the regular classroom, right?
Repeat.
Regular classroom for the marathon, right?
Yes, our classroom that we use. All right. Yeah,
Sir,
man. So
so that cannot be four.
can before. Oh gosh, you see it there? Tired man, tired. This is what 2/8 squared, huh? Yeah, man. This down here says now 4/8 square plus 16/8 4/8 square plus 12/8 square. So that's 16/8 square, right? Right? This is 4/8 square and this is 12/8 square. Agreed?
So yes.
And so the 8 square them cancel. So we get tan of alpha minus beta is 1/8. So now to find the viewing angle, we take tan inverse now. All right, that's gonna give us the answer. So that means that the viewing angle from the painting, alpha minus beta, is tan inverse of 1/8. Ooh, tan inverse 1/8. What's tan inverse 1/8? Let's put in the calculator. All right, tan inverse 1/8.
Calculators, radians or degrees?
Radians, it didn't say, so I guess we can give them in degrees. They didn't tell us, so I guess we can give them in degrees. So I'll give them the viewing angle in degrees. All right, so let's give them, what to get in degrees?
Minus 14 is equal to 7.1.
7.13, good. Always remember 3 sig fig, so it's 7.13. So that's a very small angle, 7.13 degrees.
I mean, they wrote all those words and it's not even that far off the ground. Wow. Can't believe these people. Sorry, still there? Did my internet give up on life? Anybody else can't hear, sir? Or is it just me? Hello? All right.
No, not hearing him.
All right.